Hello and welcome to this fourth video where I'm giving you a tutorial about how to make infinite procedural Perlin noise directed terrain. Right, in this video we're going to make some progress, hopefully, where we're doing the essential thing. This is where the terrain will truly become procedural. That means as we move our player or our subject around this terrain here, we've got 4x4 tiles, 16 like terrain tiles altogether. As we move around there, we want that landscape to shift and move as though we could just walk forever, go on adventures, almost like No Man's Sky will do it, or Minecraft, although we're not using voxels. Maybe we'll do that in a future video. Okay, so last video we were left with our 4x4 tiles, and I've made one very important change straight away. My driving is terrible, so I've kind of flattened the car and put an egg on it so that I feel a bit safer and everything's a bit more pink. So most importantly, we've got our vehicle to explore our terrain. Now, at the moment, when we go up to the edge, I fear. See, I can't even drive to the edge. I've skidded around. Right, if we drive to the edge, we just fall off. There we go. So at that point, or maybe before that point, we want somehow the tiles to kind of regenerate. So I've fallen off, I think about here. Oh no, that's just a mark on my screen, sorry. Right, we want to, we've fallen off, say maybe up here. And what we basically want to do is, well, we could do this in several ways. We could, say, grab this tile and then shift it over there. But then we might have a problem in our player might be over here, if you imagine, where my little hand is, on my on-screen hand, little white glove. If we're there and then we look left suddenly, there's no terrain, so it won't look realistic. So another way we could do it is find a way to shift the whole world of our terrain precisely around where our player is. So our terrain is centered on wherever our player is, and then when we get close to the edge or have moved a certain distance, we then shift all the terrain again to be centered on the player. So that's what we're going to try and do. We'll try and do that. Two things. So we'll try and center the terrain on the player, and then when the player has moved a certain distance, then recenter it again. Okay, so let's just see what happens at the moment. When we press play, and I'll just pause it, we'll see where the terrain is. It looks like we're in the bottom left corner. So I'm looking just straight down at the terrain, and there's our little egg cart in the bottom left. So first step, we need to write a function so that when the terrain manager starts, it puts all the terrain around the player. So we're not shifting the player, we're shifting all of these grids, this grid of terrain tiles to move down and left in this case. Okay, so let's bring up the code. Just a reminder, we've got two scripts. We've got our Hills Are Alive script, which is attached to our individual terrain, Perlin terrain tiles. And all that does is generate the Perlin noise terrain. That's what we did in the first video. And then we've got our terrain manager. Sorry, the little ground object is a prefab, and the terrain manager first of all initializes 4x4, so 16 of those little ground objects, and they go and do their Perlin thing. And what the terrain brain script does is arrange them in the grid. That's essentially what it does, and make sure that they're all lined up. Now we have a terrain origin, so that's the top left, the first terrain tiles position, and then all the others get shifted from that position. So that's going to be important. Right, so let's bring up Mono Developer. So we want to be in terrain brain. So this is our terrain manager. So the first thing we want to do is have a way to get hold of our player's position. So let's write a variable. Now we don't know who the player is so far, so let's just write a public string player name, and we'll set it to a default subject. I tend to call my players subjects for some reason. My main player equals subject. And then what we can do, hopefully that variable will now appear. Did I save it? Oh, no, still not there. Let's just save that. Go back to Unity. Now I'm looking for that variable to appear in the inspector. Player name, there we go, subject. In this case, I've called our player car. So, because I made it a public variable, I can write car. I just realized I didn't start the timer. Let me have a look at the time now. Okay, I'll keep this to about, I don't know, half an hour or something from now. Okay. Car, right. So we know who our player is. Right, so we want to write a function that gets hold of their transform. And the transform holds all the information about position, rotation, and scale of the player. We only want the scale, really. So we're going to return a transform. Or shall we return the position of the player? Let's just return the position. So the position of the player is held in a vector 3, an x, y, and z. So vector 3, return player pos, and in here we'll put player name, oh, and that's a string. So we've got one parameter. I'm writing it like this, using the parameter of player name, so that maybe you've got different characters that you can use this function for different objects. Okay, so that's a programming habit to kind of generalize things. Right, so all we want to do is say return, and now we need to find our player. So to do that in Unity, in C#, you write GameObject dot find, and then you can pass in a string, and it will simply look for that. Have I spelled that wrong? Player name. Oh, I see. I didn't camel hump the name here. Let's do that. Find player name. So it's found the game object, and we want to return not only its transform, but also its position, which is a vector 3. So that function now, if we call it, and we use the current player name. Oh, you know what we should do? Oh no, sorry. We just accept any player name. Okay, and it returns the position of the player. Right. So we can return the player. We want to now write like a function at the start. That's called. Oh, we don't want to lay out the terrain straight away. Before that, we want to center terrain on player. Okay. So we need to write this function. It's going to be void. It's not going to return anything. Center terrain on player. Okay, this is the important bit. Have I spelled that wrong? Center terrain on. Oh, my camel humping is going wrong. Okay, there we go. Center terrain on player. So what we need to do is change the original position of our terrain, and we call that my pos. So my pos is the terrain origin, and look, when we lay out terrain, it's using the terrain origin. The terrain origin, if we go back to Unity, is that public vector 3 where we tell the tiles, to begin to be laid out. So we need maybe I'll just write a bool to turn that off, that functionality. This will make sense in a moment. So we're going to write public bool center on player. And we'll have that as false, as default. And then we'll go back to layout terrain, and we'll say if oh, actually, what we could what we could do then is we could just change terrain O. Okay, that's what we need to change. That's what we'll do. Center on player pos. Okay, so inside our center on player, what we're going to do is change what do we call it? Terrain O. Okay, change terrain O. That's what we're doing. So we want to say terrain terrain O dot x equals and shall we grab the player? Shall we say float no, we'll say vector 3 p pos, that will stand for player position, equals, and now we can use our little function, what was it called? Return player pos. And we need our player name, and we can actually just refer to player name because that's the public string, and it'll default to subject, but we've changed it to car. Okay, so ppos now holds our player's position, and so we can say, and what we're doing is working out these three components of the terrain origins vector. So we're going to say terrain x equals something, terrain y equals something, terrain z equals something. Okay, terrain O. Right, so it's got to be the player position minus kind of half the full width of how many tiles we've got times 10f, remember, because each single tile, if it has a scale of 1, that does mean 10 units in Unity, times its scale. Okay, divided by 2, if I hadn't said that. Then it will be the number of tiles minus 1 to get us bang in the middle, I think. Let's have a look. Right, so terrain OX equals, what did I just say? I said player position. You know what might be the easiest way to do this? Firstly, is to say terrain O simply equals the player position. And now I'm just going to slide it around. It's easier for me to think of it. So minus equals. So at the moment, the first tile, the top left tile, will be bang on where the subject is, but we want to shift it kind of like forward on the minus direction on the z axis, and then again minus on the z. So we want to say minus equals all that maths. What did I just say? 10f, I remember that, times the Perlin tile. Is that what we called it? Perlin tile. So that's the tile prefab. That's what I want. So that's the prefab, and its transform dot scale lossy scale. So that's a world scale. Dot x times I've said 10f. Oh, times the number of tiles that we've got. I'll make a new line here so you can follow. times, what did I store that as? X tiles. So that's how many tiles on the X dimension. X tiles minus 1, because I kind of start from 0 with the X, minus 1. That's it. Oh, so that whole thing divided by 2. We don't want to shift the whole width. We don't want to shift the whole height. We just want to go halfway to leave our player in the middle. Okay. Okay, that's kind of going okay for the whatever this is, for the centering terrain on player. Right, so now we just need to refactor this in terms of the z-axis. So we're just essentially changing some x's to z's. So it's scale on the z-axis, z tiles minus 1 divided by 2. That should shift them up, if I've got that right. So what do we do with the y? Now I've just been thinking, the origin wants to always be the same in terms of y. We don't change anything. So we need like an original position. So terrain O. Now we've changed it here. So we can't refer to it again. So what I'm going to do is make like a special. Let's just make a special original y variable. Okay. Oh, and that's going to be a float. And what we'll do right at the beginning, center terrain on player. Before we do all that, we'll say original y equals terrain o dot y. So that stores that. Okay. So terrain o y equals original y. So what we're doing is undoing this line, this assignment of terrain O's x, y, and z in terms of the player positions x, y, and z. We don't want the player's y measurement, height, to affect the terrain's height. For example, if we've, in our little egg cart, if we've climbed up a hill, then we don't want the terrain then to rearrange itself according to the height of that hill. We want it to be where it originally was laid out, if that makes sense. Okay, about 15 minutes from when I started the clock. Okay, right. We're getting close to being able to test this, I think. I just noticed, that's now gone green, so that's okay. So let's just see what's happening. Start. Original y equals terrain's original y. So at the beginning, terrain manager, we're saying y is 0. So next we center terrain on the player. So that's our important function. So we're saying vector3p position, player position, so it's just a temporary variable, equals, and then we go and get the player's position. Okay, then we say the top left, the origin for our terrain grid equals the player's position. And now we shift that origin left half the number of tiles and so forth, and then up. So that should leave the player as though it were the player is in the middle of our grid. And then we just make sure that the terrain's y height is the original. Okay, so then what's going to happen is then we lay out our terrain. Let's just make sure that will do what we're expecting. So yes, the origin of the terrain grid, my position, equals the terrain's origin. Okay, that looks like it should work. So this is the first step in making infinite terrain. Let's see if this works. Okay, so when we ran this the first time, it looks like it's working. Our egg cart was in the bottom left, if you remember. It looks like we're in the middle. Let's just, before I drive around, pause, drag our terrain. If I click on the car, I'm sorry, but that's a result. That is, I'm very pleased. Right, our egg car is centered in the middle. That's beautiful. That's brilliant. Okay, so let's just double check that works. So if I put my egg car at 999, 45, 20, I want to leave that as 20, so it drops on top of the terrain somewhere. If we try that again, our terrain should, we've just landed on the terrain again, which is a good sign. And where's my terrain? Double click the car, and we're bang on the center. So it doesn't matter where we start our player, our subject, our egg car, our center terrain on player function works. Okay, first step down. Now what we need to do is we need to kind of record the player's position. Oh, we can do that. We've written a function that can return the player's position. And then every so often we want to just measure how far the players moved. And if they've moved a certain amount, we want to recenter the terrain. And we've already written the recentering, so we just need this measurement function. Okay, so we're going to need a vector 3 to kind of record the player's position, and then we can like write a function to check their actual position compared to their original position. So we need a private, we don't need to share this, we'll see this in the inspector, private vector 3 record player, should we just put ppos, record ppos. Okay, there we go, record ppos. And why not, let's just put in the player's initial position. So return player position, and we use the current player name. Okay. Okay, right. So we can record the player's position. Right down here, we've got our update loop in our terrain brain, which we're not doing anything with. So this is the loop, the game loop that runs and runs and runs on this script, around and around and around like a loop. We need to check. We need to check something. So we need to check player wander. We'll call it that. How far has our player wandered? Right. And then why not? We'll write this function over here. Okay. So it doesn't want to return anything. So void check player wander. I've written that correctly for once. Very, very good. So I want to measure a distance. So we do that with vector 3 dot distance. And then you put in here, as it says there, you put in here 2 vectors. So we've got our player's position and their old position, which we haven't updated. And we can see what the magnitude is, the distance between them. So we want return player position, so that's their current position. That's the first vector, and then we need the record of it. What did I call that? Record ppos. Brilliant. Right. I hate the way this has just reordered itself. Okay, so we've got the distance. We need to store that in something. So we'll call it float. So distance doesn't return a vector, it returns just that number, a floating point, and we'll call it dist equals. There we go. Right. Just using some white space, so I'm keeping the programming on the screen just in case you're coding along. Right. Float dist. So now, what's the time? Okay, maybe 10 minutes. If, maybe less. Right, if dist is more than, so if they've wandered across one tile, that would be 10f times prefab, what did I call it? Tile prefab? tile prefab dot transform dot lossy scale. It would be good to kind of store that at the start in a float, so that you wouldn't have to grab it again. That's just one way to make the code faster, although it won't make much of a difference. Lossy scale Z, it doesn't matter, I suppose, because we've got square tiles. So that would mean if they've gone across one tile. So let's see what that looks like. We really want to measure if they've gone, I don't know, we can kind of, if they've wandered more than, you know, the distance from the center to the edge, then they're going to fall off the edge. Also, you kind of want the procedural terrain to appear without you being able to kind of see that far, so that it doesn't suddenly snap into view. That's probably what we're going to see here. So let's just put, once they've crossed one tile, then we want to record this new position. So we want to say, let's just kind of like reset this as the point at which we're going to measure how far the player has wandered. So record ppos equals, and again we want to return player pos, player name. And then we need to recenter the terrain. Oh, this is an exciting bit. Once we've done this, that we've now got infinite terrain. So we want to say recenter. What did we call it? center terrain on player. Okay. Oh, so all that does is it doesn't actually then lay out the terrain again. It doesn't move the terrain. All it does is find where the terrain origin should be. So the top left tile. So it's kind of ready to lay out the terrain. What happens if we just call layout the terrain? If we call layout terrain, it will instantiate a load of new terrain. We don't want to do that. That would be very slow. We just want to use our existing tiles. So we've got to somehow loop through all of these. Can we use the same for loop? And maybe put a parameter in here. We need to somehow refer, right, no, we can't do this in here. We need an array of tiles that we can loop through in a new function. Okay, it was feeling too easy, so maybe now I've only got like just over 5 minutes. Now I'm pressed for time. So we want a private game object. So we're writing an array to store our tiles. So to make an array, you use the square brackets after the variable type, and we'll call it my tiles. There we go, my tiles. Let's write our function. We're going to write it next to layout terrain. It's going to be very similar. So relay terrain. The first thing we want to do is make sure we've got enough kind of like spaces, enough like game objects inside our array to begin with. So we want to say my tiles equals game object, new game object. So we're telling it what we're going to put in there. And how many do we want? We want X tiles times Z tiles. Because if we've got 4 tiles by 4 tiles. Oh, I'm not supposed to write that there. We want yeah, if we've got 4 by 4, that's 16 altogether. 4 by 4, 16 altogether. Brilliant. So that's really important. So that my tiles we can now use. So what we want to do, in layout terrain, we need to plop those. In fact, we don't want that there. We want to do this just once at the beginning of the game. So in here, once we've instantiated that game object, we want to plop it inside of our array. So to do that, we'd write my tiles. Now we need to know which one we're referring to, so I'll just call it I number. I number equals new t. So essentially, we're putting that new terrain tile into that slot. So in here is the index that we're talking about. So we just need that inum to get bigger every time we loop around here. So we better go and write inum. And that needs to be an int. Inum equals. So I suppose we're starting from 0, so we need that to be -1 here. So it'll be -1, inum plus plus, it'll be 0. Yes, so the first tile 0 in our array. Next time it loops around, plus plus 1, 2, 3, 4, up to 16. Okay, so now we've got hold of our tiles. So in layout relay the terrain, we need to just loop through in a very similar way and relay those tiles. Let's copy this loop. Have I got the whole thing? I think so. And we want to take out the instantiation. Yeah, we don't want that there. Inum we do want. And we do want, yes, to generate the terrain again. Remember, we call the other script. Once we've moved the tile into position, we then need to run that script on the individual tile to work out its terrain according to its new position. So we can take out the instantiation. We might as well take out this old code while we're here. We don't want new t, so now we want to refer to my tiles inum. Again, we don't know what inum is, so we need an int inum equals -1. So its position equals the terrain which we've recalculated in center on player position. And then my position, we're shifting. So now all we have to do is say my tiles inum. Oh, better put inum before that. I'm a little worried that we've got red under here. My tiles inum. Why is it not liking that? I'm scared. I'm scared of that. Right, my tiles inum dot transform dot position equals my pos, which we've just worked out. So again, very similar to how we originally lay out the tiles. We put the first tile in the origin and then we shift it according to where it is in the grid. Okay, that's gone nice and green. I think that's it. We just need to call relay the terrain. So back down to our check player wander. So just a refresh, we calculate the distance between how far we check the distance between the current position of the player and where they last were when we checked. If that distance is greater than 1 well, greater than 10 essentially, the length of one tile. Then we record their new position, we center the terrain on the player, so their new position, so we find the origin of that first grid tile, and then we need to relay our terrain. So we're not creating new terrain, we're just calling this function where, no, that's the original function, where we find the origin of the terrain, which we've recalculated in center on subject on the player, and then we build the grid, we slide the terrains around, and then we recalculate their Perlin noise. So that's truly procedural. As we move around, the terrain is newly generated. So let's just make sure I've saved that. Now it went very well last time, so let's expect some bugs, and it's about 1/4 now, so I've taken about half an hour. Is that about 45 minutes altogether? I don't know. Right, so let's just pause it. So we're in the middle of our terrain. Let's see if we can drive forward forever. I'm seeing no terrain created. Oh, I've just inexplicably exploded. I hit a bump. Okay, I'm still moving forward. Terrain is reappearing. Yes. I think we've done it. We did it. We did it within like the time. Okay, so let's just pause. So I've driven forward quite far. So there's something wrong with the collision on my car. Let's zoom out. Yes, and look, we are still somehow in the middle of our terrain. So we've created procedural terrain. That is fantastic. That's fantastic. Let's just make our terrain a bit more interesting. So we've got 4x4 tiles. What we could do now is explode that number so that we really see far in the distance, so we don't have a chance of seeing any snapping. The con of that is that it will take the computer longer to generate all of the terrain and things, so you might get like a jolt. So what you need to do is kind of balance how many terrain tiles you've got with like how far you can see, or if you're comfortable seeing it snap into place, then it's fine. So our terrain brain at the moment doesn't control what our terrain tiles look like. So that happens on each individual terrain slab. So we want the height to maybe be a bit more interesting. So let's go a bit higher. Let's go like 50 high. A gradient wants to be similar though. I don't know, let's try 25, and then oh, we've made each terrain tile 12, so that's why it's quite big. Okay. Oh, let's see what that looks like. Sorry, let's see what that looks like originally with a size of 8. So each tile is now just 1 by 1. So the edge will look a lot closer. There we go. Now if I go forward, we can actually see it snapping into place. Can we get to the edge? No, it's working. So we can keep on driving forever. Although now this doesn't look very satisfying, although we've got some better hills and things. So the trade-off, if you make each individual tile bigger, you lose resolution in terms of the bumps. But you can fiddle around, so we can make it 50 high. Is that what I said before? No, I can't remember. 25 high maybe. Keep the gradient there. And we just need to make sure that our player, our car, is at least 25 so that we don't appear in the middle of the ground or underneath the ground. Okay, now we've got some more interesting kind of terrain going on. Okay, fairly successful video, much more successful than the previous couple. We haven't got many bugs going on. Okay, so now you can wander around on this very exciting terrain and explore forever. I think I will make a next tutorial. So final tutorial will be number 5, I think, next video. we will look at making this terrain a bit more beautiful. So we've got the Perlin Noise in a more thoughtful way. Okay, thank you very much for watching. Enjoy the egg carp. Oh, I'll put a link to all this code in the description. Good evening. See you in the next video.